Hey everyone, good afternoon. So my name is Anant Agarwal, and I'm a software engineer at Instacart. And today I'm going to be talking about Temporal and data quality checks. So little about me. I've been at the company for about 4 years, so kind of joined around the first wave of the pandemic. And throughout my tenure at Instacart, I worked on building frameworks and low-level platforms within the infrastructure group. Coincidentally, I was also part of the team that brought Temporal to Instacart in 2021. At that time, it was Temporal Cloud was not a thing, so we kind of stood up our own cluster, which as of today, I'm going to talk a little bit about the numbers, runs about 2 million workflows a day. And I'm going to talk about the architecture as well. Um, so the agenda for today So the agenda for today is, in the first part, I'm going to briefly glance over how we run Temporal at Instacart, what is the scale. So some of you may have been there at a replay last year. I gave a detailed talk on how we run Temporal at Instacart, kind of talking a lot more about the architecture, the deployment principles, some of the abstractions and the tooling that we have built, which kind of have led to a rapid evolution and adoption of Temporal. So I'm going to give kind of like a contrast to last year and how we have scaled further. The bulk of the talk would focus on data quality checks, and then I'm going to impart some key takeaways from someone who has moved from building the infrastructure and the tooling around Temporal to being a user on top of Temporal and then building mission-critical applications. So talking about Temporal at Instacart. So Temporal at Instacart has been in production for a little over 3 years now. We run close to 18 million workflows per day. We run on a self-hosted cluster on Amazon. We have about 25 namespaces. Each namespace in our land is like a use case. So all the different applications that we run or systems that we run, they kind of run in their own namespaces. Up until last year, we had a single cluster which was running all the namespaces. We have since divided into multiple clusters. Some of the clusters run like mission critical systems, like our ordering and our batching flow, our logistics flow. So we kind of give them a separate cluster, a separate kind of networking configuration, infrastructure configuration, so that they don't take out some of the other systems and vice versa. And we have users who write temporal workflows in Python, Golang, and Ruby. So for Ruby, we use the community SDK developed and I think maintained by Coinbase. And then for Python and Golang, we use the official SDK. Golang is perhaps the one that is used the most, and that's where we have developed a lot of the tooling, because that was one of the earlier SDKs which was not built on the Rust core. And then Python was a more native SDK that was kind of built on the Rust core. So how we deploy Temporal at Instacart? So at Instacart, we are an AWS shop. So we deploy our services, our containers as ECS tasks. And the lowest level primitive at Amazon to deploy an isolated configuration is what we call as an ECS cluster. So a cluster is just a primitive that allows you to deploy a bunch of EC2 hosts, and then you can run your services as containers on top of those hosts. And then there is a lot of placement logic about how much configuration or resources your containers need, and accordingly it gets placed on a particular host. So we deploy Temporal in a completely isolated cluster where each and every egress and ingress rule is carefully monitored and written in code. So we are a big believer in configuration as code. So all our infrastructure is in Terraform. So this entire stack that you see, it's in Terraform, which allows us to also spin up new clusters fairly easily and kind of have a very similar looking clusters, just different in terms of resource configuration and the networking setup. Instacart developers access Temporal resources through the Temporal UI. And then for admin use cases, we deploy what we call as a Bastion service, which allows us to give a backdoor entry into the cluster. But that's perhaps the only way you can actually look at what's happening in Temporal. Individual teams who are using the Temporal services deploy their workers as ECS tasks within their own clusters. And then we set up the correct networking rules to allow talking to the Temporal cluster through the Temporal APIs, which are backed by gRPC. Our backend database is Cassandra, which we get through a managed provider. And then we have Elasticsearch configured on top of it, which for advanced visibility. One of the other things we do, since I mentioned this entire stack is in Terraform, we are able to augment a lot of the Terraform resources that are created whenever you create a new temporal cluster. An example of which is we deploy our entire monitoring dashboard for an individual cluster from Terraform because it is all code. We deploy a lot of monitors. So I talk about this in detail in my last year's talk, but we have a set of Terraform modules that are focused just on the right monitors that we feel an onboarding team might need. So it could be a monitoring setup for a completely new cluster, or it could be a monitoring setup for some of our user teams who just want to run some sort of worker. So they'll just bring in their workers. We'll give them some Terraform monitors for free. In terms of the use cases that are run by Temporal at Instacart today, so Temporal is the solution, is the orchestration solution we have given to all our teams at Instacart to develop any kind of LLM or Gen AI based application. For those of you who have used Temporal to write Gen AI applications, the signal capabilities, the query capabilities, and now with the new workflow update capabilities, you can very easily plug it into some kind of an RPC interface with a UI on top. And Temporal can do these long-running conversations with the LLM agent, with your Bedrock or OpenAI APIs, and kind of build a more robust and reliable LLM-based application. The entire payments reconciliation workflow. So at Instacart, or majority of the services today, teams rely on multiple payment providers, be it Stripe, be it Klarna, be it Braintree, some of the notable ones. All that reconciliation workflow goes through Temporal today. So it's a very mission critical piece of our entire stack. The entire life cycle of display ads. So Instacart has a huge ads offering for CPG partners. So whenever you go to the Instacart app, you'll see some ads from Coke, or you'll see an ad from Pepsi, from Kellogg's. All of that is powered through Temporal. So our CPG partners upload certain what we call as display ads. It could be a picture, it could be like a banner, it could be like a small video clip of like 2 or 3 seconds. That entire life cycle is managed through Temporal. On the infrastructure side, a lot of our tooling, and this is continuously growing, is backed by Temporal. The entire CD system is backed by Temporal. Temporal talks to ECS, Temporal talks to the Boto3 APIs, all the AWS primitives, and then it talks to BuildKite, which is our CD system where we run our workers. All of that is orchestrated through Temporal. And all the tooling that we have to create new services, to create new monitors, databases, everything is powered by Temporal. And lastly, perhaps the biggest use case in terms of scale that we have running at Instacart is the entire logistics and batching side of the Instacart stack. So batching and logistics comes when you place an order, and then we on the back end figure out what shopper is going to accept this order, and then is going to go to the store, shop that particular order, and then go ahead and deliver the order to you. So this is our largest namespace. I think it runs about 12 million workflows until a few weeks ago. And perhaps the most busiest namespace. This runs in its own temporal cluster, very isolated, and then with like more advanced monitoring because it is a very business critical application that we're running on Temporal. So moving on to the main part of the talk today, which is data quality checks. So for those of you who have worked with data teams or data systems, or in general, if some of you are data engineers, analysts, or you worked with those kind of domains, the term might feel familiar. But just to kind of set the context, a data quality check is simply generally a SQL-based validation that you write against your production data to audit it, to make sure it is valid, it's valid data. And then if there is any discrepancy at any point, whether during the ingestion time or during transformation time, you catch that discrepancy, you alert the right team who would be the owner and fix it right there. And the reason why data quality checks is important is to make sure there is sufficient trust in your data. Now, for a company like Instacart, because there is a rapid evolution of product, certain assumptions made about the data can quickly become invalidated, whether it is at the ingestion layer, whether it's at the transformation layer, or it is at the consumption layer. And if validation rules are not in place, if validation checks are not in place, the errors might be overlooked or they might be caught later in the cycle. And the impact of that is your internal dashboards might be wrong. So imagine showing a dashboard to C-level executives where some of the metrics is wrong because a bug kind of crept through the system. Or we are showing some production data to the customer, some product-related data to the customer, or the customer is seeing some machine learning model, seeing data based on some machine learning model, which is trained on top of incorrect data. So that's why having trust in your data is very important, which is a little bit synonymous with a lot of the discussion was there in the keynote today about having trust in systems. So it kind of starts with trust in your low-level systems to the trust that you build in your data, which you then show to your external partners and within your company as well. So in order to solve all of this, we built a system called DDC, which stands for Declarative Data Checks. Now, at Instacart, we have had this problem we have been tackling this problem for a couple of years. We deployed certain tools, certain managed ones, certain that we built ourselves, certain open source offerings, but we were not able to hit all the different requirements that we had. And since Instacart went public last year, there is an added amount of compliance and audit requirements that we now have to face as part of SEC and also as part of other initiatives where we need to be SOC 1 compliant, SOC 2 compliant, and so on. So one of the critical asks that these compliance standards ask of you is that any changes to key controls, a control could be like a financial pipeline, which is doing some important business reporting, any change to that has to be documented. I'm just presenting it in a very simplistic format. So if you want your pipeline to be documented, then you would also want the test running on top of that pipeline to be documented as well. Which was one of our key requirement where any check that we write, especially for the ones that are looking at critical data, we wanted version control. So in short, we wanted to be in some kind of like a source code system like Git. We wanted to store all the runs for a particular check which are running on any particular data set and store that entire history. Sometimes audit requirements ask you to store data up to, I think it was, the standard is SecPol, which asks you to retain logs for, I think, 18 months, similar with respect to checks. And while we were doing that, we also wanted to make sure that the alerting setup that we introduce in the new system is not just limited to alerting when there's a failure, when there's a basic failure of the check failing. We also wanted the system to support advanced checks where you could do things like anomaly detection and so on. And in our case, we would plug that value into Datadog, which was our metrics and monitoring system, so that we can do those advanced level monitoring. So like I mentioned, we had a proliferation of tools. None of the tools were kind of satisfying these particular requirements that I talked about, and some of the other requirements that are listed on the screen. So at the very basic level, a data quality system should be able to support multiple database technologies that your company is running. In our case, it was primarily Postgres, Snowflake, Databricks, Dynamo, and ClickHouse. So we had some tools that would support those, but it would not support a lot of the other features that we wanted. So we did want alerting. So alerting not just for Datadog, alerting in terms of OpsGenie, which was our paging solution, and then Slack, because some alerts you want to be notified on Slack as well. We wanted all the checks to go through version control, which is we wanted them to be in Git. And especially for the checks that test some part of key financial control, we wanted any change to those checks to go through a peer review process, which would mean I make a change, you go ahead and review it, and only then it's merged. We wanted to save the history. We wanted some additional compliance controls. And then we wanted to integrate the checks as a native primitive in some of the other systems we had. So a simple example is in our discoverability systems. So at Instacart, we have a system where you can see any data set, any table, any view in Snowflake, and then you can see who last edited it, what are the common queries running on top of it, what are the dashboards built on top of it to kind of give you an idea of how important a data set is. Or for example, if you just want to see, hey, I want to get the information on orders at Instacart. You're a new engineer, you want to get information about orders. So we have a system that allows you to discover those relevant tables. Now, if you're showing a table to you saying that, hey, this is relevant, we also should show you the information that, hey, this is validated. It's gone through certain checks. It's gone through certain validations. So we wanted to integrate the results of DDC into the system at the very source where new people discover data sets. And we also wanted to have very strong ownership enforcement. Now, ownership is a problem that kind of manifests itself in different ways. So if I become the owner of a system and I move around from team to team, then that becomes a problem because I won't take that system with me. The system stays in the hierarchy where I was working earlier. Or maybe I left it. I leave the company. Then again, you need to find an owner for the orphan system. You could then assign the ownership at the team level, but the problem for that might come is the teams sometimes move around, they get mixed, they get broken up. But what kind of stays is the hierarchy around which the team goes. So a team might have like a bigger team, which then goes to the engineering team, which kind of goes to at the CEO level. So in short, you want to integrate it with the team structure that is there in Workday. So we developed an ownership system that kind of maps how it is in Workday, and then we enforce ownership of each entity at Instacart, be it a service, be it a pipeline, or be it a check at the team level through this central ownership system. And like I mentioned, we wanted to have Datadog very natively integrated so that we can do advanced monitoring. And then we definitely wanted a UI for it. And the reason we wanted a UI is not just in terms of making it easy for developers. It's actually a lot of your data systems in particular, a lot of the users are non-technical users. They would be data analysts, they would be data scientists, they would be business analysts, or some other analyst in some other business domain of your company. They might not even know how to use Git. They might not even know how to check out a branch. And trust me, there are cases like that where there are analysts whose day-to-day job is not to check out Git. Their day-to-day job is to write some piece of SQL code, analyze some data using some BI solution or something. And then for them, we wanted to give them a very easy interface so that they can create the check, they can migrate checks from the older system to the new system, and they don't have any friction in the process, which is where DDC also comes into picture. So moving back to my slide here, we built DDC on top of Temporal because because Temporal allows for the reliability and the durability that we wanted. Plus, we wanted it to easily integrate with some of the systems we had, and the very concept of activities run through workflows makes it easier that we can build a plug-and-play kind of a system, which I'll show in the architecture that I'm going to talk about in a few slides. Okay, so I've talked a lot about checks. These are some examples of checks. So in DDC, we support two kinds of check. One is what we call as a list mode check, and the other is called a metric mode check. So a list mode check is simply runs the SQL, grabs a bunch of data, and then you decide what is the failure condition. So you write a piece of SQL code saying that, hey, list me all the ID and versions of the different brand pages I have in my ads table. So if this returns 0 rows, which means there's an error somewhere, and this has to fail and then alert. And you decide what the alerting means. Or you could say that, hey, if I get more than 100 pages, that is also an error. So you kind of decide what condition becomes on which you fail. In case of the metric mode, depending on the use case, you decide what is a metric that you want to compute. And then in your SQL query itself, you kind of define that metric as part of your select query. So a metric could be a counter. You could add tags to that metric so you can analyze that data further. And this metric then gets sent to Datadog, where you can build some monitoring on top of it. You can even do anomaly detection. And this is the architecture that we came up with when we built DDC. So the main thing I want to talk about here is we build the architecture in kind of a plug-and-play way. So if you start with the bottom, you'll see that we have a query engine there. Now, the query engine interface accepts any kind of database technology that you can bring in, as long as there is a programmatic way to talk to that database engine. So in our case, it was DynamoDB. The databases we run were DynamoDB, Postgres, Snowflake, Databricks, and ClickHouse. And if tomorrow we introduce another database in our stack, as long as it has a driver, an SDK that we can use, we can plug it into the DDC system. On the other side, we have Datadog, where for each check, we send an event, we send a metric. It could be replaced by any other monitoring solution, as long as it supports the metric primitive and the event primitive. Once we run a check, which is just executing the SQL through a DDC through a temporal activity against that particular database solution, we save the results in S3 so that it can be viewed easily, it can be downloaded, it's persisted. And then the place where we get the check, so we integrate it with our GitHub system, it could technically be any version control. So it could be Bitbucket, it could be GitLab or something else, or any other system that that different people use. And a check is stored there as version control, just like any source code file. The DDC engine reads any change in certain directories where we look for the checks. And then it creates a workflow, a long-running workflow, where each activity then queries the database, gets the result, saves it to S3, sends it to Datadog, and then depending on the failure condition, it then alerts to Opsgenie, it alerts to Slack, depending on what you have specified. So it kind of is a very plug-and-play way. If you say that, hey, I don't want Slack alerting, there's an easy way to turn it off. Hey, I don't want Opsgenie, I'm replacing it with, let's say, PagerDuty, there's a very plug-and-play way to do that. So, and on the check management itself, so we have a launcher service which reads from one of our repos. So we have a repo called Carrot, which is our main mono repo, although DDC technically works with any repo that might be there in your organization. Upon each merge to this repo, it triggers a build which identifies if a change has been made to a check or a new check has been added. It then creates a cron workflow, a scheduled workflow for that check. The check does its job, talks to the database, runs the query, saves it in Datadog. We also save a lot of the metadata in a metadata store, so we can easily power a UI on top of it, or we can save some history around audit and so on, and then sends the results to S3 as well. And if there's a change to the workflow, it deploys the workflow with the new config. If there's a new workflow altogether, it creates a new workflow. And if it says that, hey, I don't need to run the check has been deleted, it then goes ahead and terminates the workflow. So this launcher service kind of orchestrates all that logic on top of the temporal components. So that was DDC, and I'm going to talk about some key takeaways that, from my perspective, you should all focus on if you're building a system like this or you're building something using temporal. So one of the things that I talked about earlier is we want to make any kind of data system that we build easily accessible and easy to use by both technical and non-technical audience. There could be managers from like the business side who might want to create a check because they work with some of our CPG partners. So for them, we gave them a UI, which is the screen on the left. So you just specify the type of check you want, the database against which you will run the check, and a window where you write your SQL query. We integrated our own internal AI agent here who can help you write the SQL query once you give it some text. And it can also be used to correct your SQL query if you want. We have some other validation buttons here which make sure it runs on the particular database you want it to run. You could also do it in the CI, which is what we do like as an additional validation. And then once you validate the query, it asks for certain other form fields and it creates a GitHub PR for you. So for anyone who is not that familiar with checking out branches locally, this workflow creates a PR for you with the check. You just have to get it reviewed and merged, and it then the check gets scheduled. And on the right side, we also built a migration workflow, again built on Temporal, where within just a few inputs from the user, we are able to migrate a check from our older system to our newer system. And the advantage was that both the systems were defined in some kind of a YAML format, or they had some representation in the database that made it very easy for us to build a workflow for it. So again, some of the non-engineers who want to migrate some of their checks to the new system, they just had to go to a UI, fill out a few fields, and get a PR approved. The second one is investing a lot in alerting and monitoring templates. And at Instacart, we do it through Terraform. So you have the check, all great, that the check is running, it's catching issues. But the most important piece of it is it has to alert. And some of the compliance controls is that it has to alert. No one can turn off the alert. And any changes made to an alert has to be documented and peer reviewed. That's why having your alert definition as code, either through like a Terraform module or just using the Datadog's Terraform provider, makes it very easy for you to not just create the checks, but also create the monitoring template along with it, the monitor along with it. So we have this template. We again have a UI where you can fill out a few fields. It creates the Terraform PR for you. That gets merged, and then any change to that monitor, whether someone turns it off, changes what the alerting policy is, all of that then gets documented and is peer reviewed. And the last one is, and this is the same slide I showed in my last year's presentation as well, because this particular feature, replay testing, has helped us catch so many errors. It has prevented so many incidents from happening. So replay testing, like quick summary is, it allows you to run your the new changes you're making to your workflow on an old event log. So you can catch issues if it breaks determinism in any way. We automated it by building out a workflow event scraper, which runs through your old event log history, puts it in S3, and then in your CI system, if you're making any changes to your workflow, it's then going to fetch that event log, run the replayer code against that event log for the new changes you're making, and then fail the CI. So we don't let any non-deterministic changes to the workflow kind of creep through. And this particular piece has been so valuable for us in both our Python and in our Go SDKs, that this is something I would highly recommend anyone to have. And with that, it's question time.
Raise your hand if you have a question. I'll bring the mic to you.
So, do you have a strategy for reproducing production issues in your test environments, and what does that look like?
So for Temporal in general, or specific to DDC?
Yeah, maybe for Temporal in general, or specific to the problems that your data checks are solving in DDC.
Yeah, so the way we do for DDC is like our checks go through like what we call as an asset lifecycle process. So at Instacart, we use this term called data assets, which could be a table, a check, and so on. And then we have a process where once you merge in a check, you then that check is what we call as beta check. Then it runs through a couple of iterations. It goes into what we call as production. And then once it goes in production, it's maybe catching issues there, or it was in production in beta mode. So what that means is we don't alert it as like a P0 alert. It's not waking up anyone in the night. But once you take it from a beta to in production to active, that's when we kind of turn on a lot of the knobs. So we have a couple of stages before where we are able to catch issues. We're just not able to raise them. So let's say I wrote a query which is not catching every use case. So I'm able to run it in production. I'm able to catch the issue, still not make it a P0 alert, and I'm able to fix it. And now the check, when it is active, it's now going to make sure that it's handling all the cases that I kind of fixed along the way. Also, another technique that we don't quite have yet is because a lot of the data we have, we can't easily say that this is dev or this is prod. So a lot of the testing we do is actually on the prod data, especially when you want to do like testing on the data that is coming from your main application. Because we don't have like a beta, we don't have like a very sophisticated testing environment in that sense, at least for the data side. So that's why we do test on production directly, but we have this lifecycle process that allows us to give some control over it.
Do you have any use cases to support the more complicated SQL queries? So let's say that sometimes one single query is not good enough to support the use cases, so you can just allow the users to run the multiple queries and get all the result and having another result, those kind of use cases.
Yeah, so if you have a use case where, let's say, you want to query data from 3 different tables and then build a validation on it, the philosophy we have is that should be a view. So you should create a view in Snowflake that you can then query as much time as you want. So we discourage running checks on top of multiple tables together. And then one thing I didn't mention is like we have a very strong dbt ecosystem as well. So if you feel like your check has to run on 5 different systems, there's an easy way to create a view using dbt, and then you can run your check on top of that.
Okay, that's all the time we have for questions now. But if you have additional questions, you can find Anant outside, and maybe he'll be able to answer those. I want to thank him for a great talk. Let's give him another round of applause real quick.
Thank you.